Welcome to the next installment in the Contact Manager project. This is section 4. In this section, we're going to just get some practice coding a class. And so what we're going to do is we're going to create the second part of what will become a contact in our Contact Manager. And that would be, we want to pair a name with an address. So we're going to construct a class that will keep track of addresses for us. So therefore, we're going to have a class, but this time we're going to get our code a little bit differently. For those of you who are following along not using Eclipse, this is probably how you've been getting the code all along, but for those of you who have been using Eclipse and are importing the projects, this process will be slightly new. So what we're going to do is we're going to switch to the website here. That's mchs-cs.com. Go to AP Computer Science and click on the Video Lessons tab, and then the Contact Manager Part 1 video section. Scroll down until you can see the Contact Manager Part 1 code section, and at the very bottom here is the address.java class. Now you'll notice that if you look at this class, it's almost all commented out code, and in fact most of it is comments or Javadoc comments. But there's one little section that's not, and that's the main reason that we're going to get the code this way. So we're going to click download to go ahead and download our file to our downloads directory. And then we're going to switch back to Eclipse, or actually switch back to your system file navigator. For the Mac, that would be the Finder, and then locate that downloads folder where you stored the file that we just downloaded, and you should see a file called address.java, and you're going to go ahead and drag and drop that into your default package. It'll prompt you as to whether you want to copy the file or link. You most definitely want to copy the file so it becomes part of your project's folder structure. And now we have address.java. Go ahead and change the name to match your name, please. And then we're ready to get to work. So what is the address class going to do for us? Well, an address is made up of a string representing each of these: the street address, the city, the state, and the zip code. But as we're reading each of these things, we're going to validate them to make sure that they're always valid data. Just like we did for the name, we don't want any null values. But in addition to that, we're going to do some extra validation on state and zip code, because a state should only be a 2-letter capital code that is one of the 50 states. And a zip code should be all digits, and it should be exactly 5 digits long. So we're going to write some code to make all of that happen. Now the first thing that you'll notice is that we actually have a constant declared in the address class. And what this constant set does for us is it creates a string array called state abbreviations that is simply a list of all of the 2-letter codes that make up our states. We made it public so that other classes can gain access to this information to use it. We made it static because you don't actually have to have an address to be able to gain access to this information. Final is the Java keyword that makes something a constant. And then, of course, it's a string array. And in Java, best practices state that when we're making a constant, we capitalize all of the letters in the variable name, and therefore when we want to put 2 words together, we use an underscore to separate the words. So we have state abbreviations equals, and then a list of each of the states as a nice simple string array. Okay, so what we're going to do is look at the methods that we're going to write. The first one is going to be, we're going to be given a string, and this method is going to return true if the uppercase of that string matches one of the standard 2-letter codes for one of the United States of America. We're going to get a parameter that's going to be a possible state, which is the string that we're going to check. Then we're going to return true only if possible state is an upper or lowercase 2-letter state abbreviation. So what we have here commented out is the beginning of that method, which has been written in. So all you have to do is uncomment it and add your curly braces, and you're ready to start coding. So if we're trying to first validate that this is a valid state, the very first thing that we're going to want to do is make sure that somebody hasn't given us a null value, because if they have, then it's not a valid state. So we're going to say if possible state is equal to null, then we want to return false. That is not a valid state abbreviation. Next, we want to start checking to see if it is a valid state. And so what we're going to do is we're going to do a little work first. We want to actually compare to each of these uppercase versions of the state. So we're going to say take possible state and set it equal to itself made into, did I misspell it? Possible state. Yes, I misspelled it. Dot to uppercase. So we've just converted it to an uppercase string, and that'll make our comparison easier when we're trying to check to see if it's one of these two-letter codes. Now we're going to go through, and we could write a traditional for loop where we say for int I equals 0, I is less than, how many states do we have? Well, we can ask our state abbreviations for its length. And we could certainly write our code this way and say we're going to check to see if state abbreviations of I is equal to, oops, we don't do it that way, we do dot equals possible state. Then we're going to return true. Let's write this the longhand way. Okay, if we get to the end of our loop, that means we haven't found a match, so it must not be a valid state. Now, is there anything else we could do to improve this, or to change the way we've done it? Well, let's look at this. Did we actually need to convert this to an uppercase string? Couldn't we have done that right here? Possible state dot to uppercase. That saves us one little line of code, and basically it's the same thing. We're just converting it to uppercase, then doing our equals method. Well, next, this is a traditional for loop. Can we rewrite this in a way that uses a for each loop? In a for each loop, the first thing that you have to say is what the type of each element of the collection is. In this case, I have an array of strings, so each individual member of the array is a string. And then I have the state to check. And that state to check is going to be a state from my state abbreviations. And then here in my if statement, I use the variable that I just created, the state to check, to see if it's equal to. Now, is that better? Well, it really depends on your preferences. But the important thing is that if you see code written this way, you must be able to read it and understand what it does. Okay, so what other methods do we need to do? Well, we want to write a method that validates whether or not a zip code is a valid zip code. What defines a valid zip code? Well, it should be a 5-digit string, which means it's exactly 5 characters long, and each character is a string. Now, what we're going to do to give you some practice here is you're going to stop the video, and you're going to write the rest of the methods that make up this class. So let's take a tour of the methods that you'll be writing. First of all, you're going to write a method that determines if a state is a valid, or if a zip code is a valid zip code, which means it has 5 numbers in it. And then we're going to create some instance variables. And those instance variables are going to need to keep track of a street address, a city, a 2-letter state abbreviation, and a 5-digit zip code, all of which are actually going to be stored as strings. Now, could a 5-digit zip code be stored as a number? Well, yes, it could, but what would happen if there were leading zeros in the number? Now, as it happens, zip codes don't have leading zeros, but we're going to just eliminate that problem by treating it as a string. So you're going to write a default constructor that will make all of those empty strings. Then you're going to write a constructor, an overloaded constructor, where you're given a city, or rather a street, a city, a state, and a zip code. For each one of them, if they're null, you should make them empty strings. For each of them, you should also validate them. What does validate them mean? Well, in the case of a 2-letter state abbreviation, first turn it into an uppercase string if it's lowercase, and then second, determine if it's a valid state abbreviation. Is it, in fact, one of the 50 state abbreviations from the list? And of course, we've just written a method that makes that very easy. And if it's not, make it null. And then, of course, you're also going to do the same thing for your 5-digit zip code. Next, you're going to write a series of getters. These are very simple methods. All they're going to do is they are going to return the street, city, state, and zip code. Next, you're going to write a toString method, and the toString method is going to return a string that lists the street. Then it's going to put a new line in so that it wraps around, and then the city with a comma, then the 2-letter state code, a space, and then the zip code. That's a properly formatted street address. Next, you're going to write setter methods for each of the fields that you've previously defined: street, city, state, and zip. And don't forget, once again, they should validate each input to make sure that they're never null and that you can't set the state to an invalid state. It must be one of the 50 state abbreviations, and also a zip code must be a 5-digit number. You can check back on the website to see a finished version of this code when you're done to check your code. Get to work.